excellent question and answer article on fall armyworm for EDN issue, that's Eco Development Notes, issue 165. And I put that in the chat on the Whova app if you want to access that. Dr. Hruska has an extensive career serving smallholder farmers. He's traveled a lot in Central America, places like Honduras, spent some time at Zamorano, Chile, Panama, working with the FAO there, and also in Rome, and more recently at Michigan State University, where he's helped to further their international agriculture programs. And so please welcome Dr. Ellen Hruska.
Okay, good day, everybody. And first I want to thank ECHO for inviting me to be here with you today, to Grace and Tim, Stacy, Cecilia, all the great team that has made it possible for me to be here. I greatly appreciate the time being here with you and interacting with all really fascinating, interesting, inspiring people. So thank you for that. Tim mentioned I've worked with fall armyworm for quite a while. I did my PhD dissertation on it a long time ago, and then had the opportunity to continue work with FAO. And I'm going to tell a story about the fall armyworm, but also, more importantly, about crop protection in general, and especially what I call dominant narratives that are put out for large-scale production. And corn is a great crop to compare from large-scale industrial production here in the US and smallholder production, which many of you are intimately involved with. So that's what I'm going to do today. And oops, I guess I have to do two things at once. So some of the key takeaways from my presentation. So, I'm sorry, I have maize here. So I worked in Europe a lot, and they use maize as corn, same thing. That's the word they use in England for corn. Sorry about that. Didn't change my slides. But so not all corn is grown the same. It's the same plant, same species, different varieties, but grown, as you know, under completely different conditions, not just ecological, but more important, socioeconomic in the farmers who grow them. So smallholder maize farmers in the tropics have very different goals and possibilities in the maize production and protection, and we'll dig down into that a little bit. Context really is everything, as it is in most things in life, but in terms of corn production and managing fall armyworm, it really all depends on the context, as most of you here are acutely aware. So one important difference that I'll dig into is how corn is supported production in the US versus how it's not so much supported in sub-Saharan Africa and Asia, and what that means for the farmers and their management options. So common paradigms that we hear often in crop protection should really be viewed with skepticism from the viewpoint of smallholder production. And I'll tell you more about that, some specific examples along the way. The good news is that there are many effective, low-cost, accessible, and safe options for managed fall armyworm in the smallholder context. And towards the end of the presentation, I'll dig into some of those options. I'm not trying to sell you silver bullets because context matters, but I am going to point to some of the ecological principles, the agroecological principles of managing fall armyworm that are important, that I hope that you all engage with as you continue to work with farmers and organizations in their context where they grow maize or corn. And finally, I think really important is for continued partnerships, building innovation, communication. The eco community is one great space to do that. Between researchers, the researchers in countries. I'm working currently with researchers in Malawi and Kenya who are great people, researchers at their local universities. They need to be connected to people who are in the field, and sometimes you all bridge that gap because you're in the field supporting smallholder farmers. And it's also important that those researchers in places like Malawi, Kenya, et cetera, are connected to the greater international world of research. And that's the space that I operate in and try to build those bridges. That's part of the reason I'm here today. So fall armyworm, I think many of you are acutely aware of it, but I'm going to go through some basic stuff so we're all on the same page. Spodoptera frugiparum is the Latin name for the fall armyworm. It's native to the Western Hemisphere, so in the Americas. It's here, actually it overwinters now in the southern tip of Florida, and the most southern parts of Texas. Those are the two spots where it overwinters in the US. And then every year it migrates up to as far north as Minnesota, then into Canada, Manitoba, et cetera. And those are migrations every year. So it's a really strong flyer, the adult moth form. It can disperse very quickly, and that's part of the story in terms of how it moved from its native habitat to new areas. And in 2016, it was first reported in Africa. So it's native to the Americas, been here forever. When I did my PhD dissertation in Nicaragua on the species, it wasn't in Africa and Asia yet, and that was first reported in 2016. Coincidentally, that's when I moved to Rome to become a technical officer and inherited or took over the management program for fall armyworm as it invaded new spaces. So here's the picture on the right there. Oops, I'm not moving away, sorry. Okay, here it is. There's the larval form, the one that causes the damage in the corn or other crops. The adult form, we'll have a picture of it later. The moth that flies so well, as I mentioned. And it produces some dramatic-looking damage. But we'll talk about what that damage means in terms of yield loss in a second. So as I mentioned, it first was discovered in Western Africa in 2016. It's a map of just 4 years, just showing how quickly it moved. Again, the adult form, the moth being a really strong flyer. 17 spreading across Africa, 18 finally reported into India, 19 into China, Southeast Asia, and then since then it's continued to be reported. It's now, of course, across Australia and now into Europe. So it just continues to move. So I mentioned I got to Rome and fall armyworm invaded Africa. I was asked to coordinate the global program for the fall armyworm. So what I'll speak to now is based on that experience of working with smallholder farmers and their support networks, organizations like your own, national ministries of agriculture, and others trying to support the management of fall armyworm in the context of smallholder corn production. Okay? So as I mentioned, corn is an extremely interesting crop to make these comparisons. Fall armyworm moved to these new geographies, but more importantly, it moved to a new type of farmer. Because most of the corn farmers in sub-Saharan Africa and Asia are smallholder farmers. And I'll show you a graph on that in a second. So this just shows a picture of that great contrast of Iowa production of corn, really high productivity, mechanized, and on the other side, a woman growing her corn crop, I think in Tanzania. So some of the characteristics of corn production in the US, because we have to make this contrast between how it's supported in the US versus how it's done by smallholders. First of all, corn production in the US and other countries of the world have extremely high yields. I mean, it's one of the crops that is become a wonder crop. The increase in production per acre or per plant has been tremendous in the US. Very high yields in the US. Second, it has, the farmers have these very mature, massive, actually now globalized and diversified markets to sell into. So they're selling into these markets that are all around the world and are supported through some important mechanisms, kind of guaranteeing a good market for them every year. And finally, I'll talk really quickly about the subsidies in the US, because one of the economic underpinnings of the corn production in the US is massive subsidies that the US government provides to corn and other commodity producers. And we'll talk about that, but it's just important to understand that economic underpinning, and again, in the contrast of what smallholders face. So corn production in the US is used, and you can see some dramatic change. This is the use of corn in the US over time. And you can see some important changes here. In the 1980s, most of it was a blue, which was for animal feed. So most corn in the US, I think you all know, we all know, is not, we don't eat it. It's not popcorn, it's not sweet corn, although that's also corn. It's a very small percentage of all corn. Most of it in the 80s used for animal feed, domestically, and now internationally very important. But then beginning in the 2000s, you see this orange production selling into the alcohol market, ethanol production. So in the early 2000s, important federal legislation mandated the use of ethanol in gasoline. I think you're all aware that the gasoline we buy in the US by law now has, I think it's 10%, 10 or 15% minimum ethanol production content in the gasoline that we buy. And that was mandated in 2005 and then 2007 under some federal legislation. And that's why that orange goes way up. So most of the corn in the US is being sold for animal feed or ethanol production. And then the gray is a little bit, it's called other feed, seed, and industrial use, high fructose syrup, as well as other uses for corn, including the sweet corn and popcorn that we eat. The US government provides very large subsidies to certain commodities, certain crops, corn being the most significant. Over 25 years, from 1995 to 2021, the US government's provided over $400 billion of these subsidies to farmers. And we won't get into why they do that, basically to ensure food security and politics around maintaining stable production. But it's very important in the US, $400 billion in 25 years. Most of that comes via direct support to farmers around price supports, guaranteeing that they will receive a price for their crop based on a couple of previous years of sale. So again, they're able to project prices and costs very well on that. Another really important factor of a subsidy program is that the US government subsidizes private insurance. So all corn farmers and other crops can buy insurance for losses, and that's through a private market, but the US government subsidizes that highly. So corn, that I showed a slide of $400 billion in total, 25 years, is the most subsidized crop of all those crops. Typically, per year, it receives about $2 billion of subsidy in the US. But I happened to come across this one figure from 2020. During the pandemic, there were lots of extra money that flowed out. And in 2020, the government provided $9 billion of subsidies to corn. So just a really important consideration thinking of the economics of corn in the US. So that economics provides an incredible context for farmers to invest in their corn production, invest in the seed, in the fertilizers, the land, the machinery, and that produces these really high yields. So I just want to understand the drivers behind where we are in the US for corn production. US farmers do face fall armyworm, and sorry about this, oops, scary looking picture here. Okay, that one. This is kind of a headshot of the adult moth version, right? So he or she, because she can lay the eggs, flies around and lays her eggs on corn plants. US farmers manage fall armyworm using genetically modified corn for the most part. Most corn production in the US has two types of genetically modified organisms in. One to allow the farmers to spray herbicides over the crop. That's called Roundup Ready crops. But we're going to talk here about what's called BT corn, BT being Bacillus thuringiensis, a bacterium. And what they did was they took a gene out of that bacterium that produces a toxin, a poison, that kills the fall armyworm and other Lepidoptera. Okay? So when the larva, back to the first slide of the larva, it bites the corn, it is ingesting a toxin. It's a crystal that goes into their gut, and because of the pH in their gut, it kills them, protecting the plant. So it's a pesticide in the plant. So US corn production, and I just have to go in a little bit about economics again, and sorry about all the numbers on the slides. Look to the far right, 2016. Important, I just want to give you a sense of the figures here. So gross value of production, $600 per acre. So that's what farmers, the value of their production. And then there are costs below that, operating costs. And the first three, seed, fertilizer, and chemicals, I just want you to take a look at and just get a sense of the numbers. If you add those three, seed, fertilizer, and chemicals, and first three on the right there, it's about $250 of cost, okay? So again, farmers in the US invest about $250, a little outdated now, it's actually closer to $400 now, if we have 2023 data. But a significant investment in their corn crop via seed, fertilizer, and chemicals. Also, it's interesting to note in this table is how, if you look across from 1996 to the far left, and look at seed and chemicals, the first and third of operating costs, you'll see that seed goes up significantly. It went from $26 per acre in 1996 up to $98, call it $100 per acre in 2016, whereas chemicals didn't go up very much. $27 in 1996 on up to $36 in 2016. Why is that? Because of GM corn. So if farmers don't have to spray the chemicals to kill the bug anymore because the genes are already in the seed, and now the farmers are paying the companies a license to use the intellectual property of the companies that develop this technology every year, and so the cost of the seed has gone up very significantly because it incorporates some of this pest control in it via the GM, the new genes. So in the US, when GM corn was introduced in about 1996, it began to take off. And currently, across the United States, about 85–90% of corn farmers use GM corn, again, for both traits, for both the herbicides as well as insect control. But it's kind of leveled off at that level. Some farmers, again, wanting to produce organically or without that. Sweet corn typically does not use GM maize, corn. So it's kind of leveled off there. And in fact, in the last few years, there's been an interesting conversation, especially among corn producers way up north, like in Minnesota, because they know that they're paying up front via this license fee of, let's say, $30 to $40 per acre is what they pay to the companies to get the genes in their corn. But a lot of farmers way up north realize, yeah, but these insects aren't even doing that much damage. I'm paying up front this cost. Why should I do that? So there's a little pullback from farmers, for example, in Minnesota. So the Minnesota Crop News, the extension agents started to talk to the farmers about what that might imply, because farmers in Minnesota began to back away from having to pay the extra fee without necessarily needing, because again, falling worm doesn't always get that far north, although there are other insects there, but they feel like they're paying for nothing, for no use. Okay, yeah, I'm sorry, I'm not keeping up with the slides I'm showing you. So there's the increase use by farmers, took off in 2000, and again, it's kind of plateaued around 85–90%, depending on the trait and where you are. And there's just a notice from the Minnesota extension people talking to their farmers about what's happening if you pull back from using GM corn. So now let's go to the other extreme, smallholder production in sub-Saharan Africa and Asia. Most of what I'll talk about is my experience in sub-Saharan Africa, where I worked very directly from 2017 to 2019, traveled extensively, worked with a lot of smallholder farmers, their extension services, and their governments. And so let's just look at some characteristics of those smallholders. First of all, in sub-Saharan Africa, tens of millions of smallholder corn farmers. Interesting is that we don't even have good data about this. I mean, you look at the World Bank and you look at others and you ask per country, how many smallholder corn farmers are there in Tanzania? And nobody knows. Literally nobody knows. So these farmers are really under the radar screen in many senses, but they are the majority. And for corn, they represent 98% of the corn farmers in sub-Saharan Africa, we're talking about here. And across Africa, they produce most of the corn by far. 34 million of the 37 million hectares of corn grown by smallholders in sub-Saharan Africa. So if you're working in sub-Saharan Africa, it's basically smallholder production, with some exceptions we'll talk about. So that's true, of course, as you know, not only of corn production, but farms in general. And if you look at this great map of the size of farmers' fields, which basically can say size of farms, we see the blue being larger farms, large farms, and the orange and yellow being smaller farms. Dramatic difference between US, South America, Brazil, Argentina, Uruguay, Europe, Australia, and then South Africa, the country of South Africa, versus the rest of sub-Saharan Africa, Asia, including India, China, and Southeast Asia, where smallholder production dominates by far. So smallholder maize or corn farmers in sub-Saharan Africa, and this is a generalization, but they basically are producing first for food security at home. And then they also sell some corn. They often sell on local markets where they receive low prices, and there's great instability about those prices. And they don't have access to those international markets, the ethanol production or animal feed. They don't sell into those markets at all. The only ones that do are those farmers in South Africa, which are a different case. As a consequence, and so they have no subsidies. They don't receive any subsidies for their production. And as a consequence, corn in sub-Saharan Africa is basically a poor person's crop because they're using it to eat and feed their family. And as such, they don't invest much in their crop. So again, comparing with the US, we have the ability to invest in genetics and seeds and machinery and fertilizer. That's not true for smallholders in Africa. If we look at the use of inputs across countries, and this is not just corn, but all crops, some data from the World Bank's surveys show that overall farmers use very few inorganic fertilizers and agrochemicals, at least about 10 years ago, with the exception of certain countries that provide programs to give away fertilizers, such as Malawi. So, oops, I'm sorry, got to catch up with you. Okay. So here's the graph showing low input use. And again, the blue is agrochemicals and the orange is inorganic fertilizers. Some countries, like Malawi, the second one, and Ethiopia have had programs to give away fertilizers or subsidize them, so there's greater use. But basically, if you look at other countries, Niger, Tanzania, Uganda, very low input use. And this, again, is not just corn. These are all crops. And corn is even more reduced because it's not at all a cash crop to them. So typically, very low input use, again, because they can't afford to. It's not because they don't know about it. It's not because they don't know that it works. It's simply not in their economic calculations. So, and just to give you some figures, remember back to the table of US production figures of $250 of inputs per acre. I did a quick calculation of, for a corn farmer in Africa thinking about managing the fall armyworm or other pests, how much could they spend per, this is per hectare on fall armyworm or insect pests in general. And this quick calculation shows, and again, largely based on the lower price they receive, okay, 5 cents per kilogram, the lower production that they have typically, that they can afford to spend less than $12 per acre on their management of fall armyworm. So just contrast that with the figures we saw where they're spending over $100 for seed alone, plus $30 for pesticides in the US. Okay. So beginning 2016, when fall armyworm hit Africa, and it caused furor because fall armyworm does cause this very charismatic, dramatic-looking damage, and farmers saw this for the first time in their fields, and they were alarmed. And so they saw this damage, and they quickly talked to their local extension people, or talked to their chiefs, or talked to the Ministry of Agriculture, and then the Ministry of Agriculture calls FAO and says, come and help us fix this problem. But because it was new and alarming, and people hadn't seen it, especially farmers, it caused a lot of commotion, a lot of publicity. And unfortunately, that panic, which I would characterize the situation in 2017, led to many bad decisions, as panic situations often do. In 2017, farmers began, ministries of agriculture felt political pressure from their farmers, locally at a national level, and they went to donors like USAID and the Norwegians and the Brits and said, please give us money so we can buy pesticides to give them away. And they did that. So there's a picture on the right of a Minister of Agriculture giving away some pesticides as a demonstration that the government is doing something to support the farmers. Other cases, the top one on there is actually a mayor of a small town in Rwanda. He went out to show his people that he was taking action to spray the fields. And then in some cases, it was also Rwanda, they sent the army out to spray the fields. So it created this panic and a reaction, which is in the long run not the appropriate reaction, but that happened. Unfortunately, that panic was also stimulated a little bit by some of the scientific or other community that fell into this narrative that fall armyworm is causing dramatic yield destruction and hunger. And that was a narrative that we heard a lot in 2017. And unfortunately, there was even a report from CABI, some of you may know it, a reputable, respected organization in the UK, and they put out an estimate of billions of dollars of damage by the fall armyworm, unfortunately. So let's just take a second to look at the real question about how much yield loss in corn does fall armyworm actually cause, because that's the basic question for a farmer. Those early assessments, including that CABI that I just showed you, were all based on interviews of farmers. No data collected at all. They went out and said to farmers, do you think fall armyworm, this new pest, is causing lots of damage? And when the farmers said, yes, it's a terrible pest, they noted that and said, okay, total loss. So they did that many, many times and came up with these figures of billions of dollars of yield loss, inappropriately, because it was based on farmers' surveys rather than actual data. So that sort of supported this whole idea that we've got to get out there and pump pesticides into the system. I'm going to take 1 second to drill down on some data. So we do know a lot about corn yield loss to foliar damage. Why do we know that? Because there's been a tremendous amount of research done in the US and elsewhere on it, and in particular by the USDA. Because as I mentioned, the US government subsidizes private insurance to farmers. And some of that insurance includes insect damage, or more importantly, hail damage, which is also leaf damage. So there have been many, many studies done over many, many years, and there are these handbooks that you can go find online which demonstrate the data on yield loss from foliar damage. So let's look at this complex table, and I'm sorry about all the numbers, but look across the top. It says percent leaf area destroyed. So these are simulated studies where they actually go and cut a certain area off the leaves to defoliate it, a certain percentage. And if you look right in the center, let's say under it says percent leaf area, 50%. So that's when you destroy 50% of the leaf area of the corn plant at a certain stage. And all down there on the rows are the different stages of the corn plant. 7-leaf stage, 8-leaf stage, blah, 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 all the way down to mature corn. So all these studies did leaf defoliation, different percentages at different stages of the corn plant, okay? Interestingly, if you look just at the top line, the first one, 7-leaf stage, you can defoliate a 7-leaf stage corn plant 100% to the far right column, 100% of leaf damage at 7-leaf stage, and it only loses 9% of the yield loss, because the corn plant is so overbred, let's just say. It has tremendous leaf area, photosynthetic capacity to produce that corn, that we've sort of overdone it with the corn plants. It has far more leaves than it needs, in fact, in photosynthetic capacity to produce the couple of ears of corn that it will produce. So at a 7-leaf stage, young plant, if you remove 100% of the leaves, it's only going to lose 9% of the yield. If you go down, you see some figures getting up there. If at the 15, 16 stage, you are going to get some 50% loss with 100% yield loss. But go back to the middle of the table, look down the 50 line, which is a lot of leaf loss. Even the pictures I showed you, the fall armyworm damage, don't approach 50% leaf damage. But if you go down to 50%, you'll see that even in the later stages of corn production, let's say 13-leaf stage, is where you hit 10% yield loss. Again, the corn plant has a tremendous capacity to produce, to compensate for that leaf damage. It can grow new leaf area, basically, or even at later stages, it's already have enough leaf area out there to produce those 2 ears. So the data has been studied for many, many years, and this over-dramatization of the yield loss from fall armyworm is just that. It's an over-dramatization. Fortunately, we also have some field studies now from Africa that didn't just look at US corn simulated studies, but actually look at damage, fall armyworm damage in farmers' fields. This was the first study done by Frederic Baudon and colleagues in Zimbabwe. And this study quantified the yield loss to smallholder corn production in eastern Zimbabwe and found a 10% yield loss to corn production under the smallholder conditions in Zimbabwe, under existing conditions. Other data are, okay, so there's the study I mentioned, published in Scientific Journal. Other data are this. When I was at FAO, we began a digital app program called The Famous, which does a number of things, but most importantly, here's what I circled in red. Allows people to look at maize corn plants and estimate whether or not it's infested. So we have a lot of data now, and in fact, well, this is from last year, done for 6 years, 2,714,000 plants checked, okay? A lot of plants checked all across Africa, basically, some in Asia too, of which 500-some thousand were infested with fallen worm. So all the data from across Africa and Asia show that, you see certain photos and images of that damage and yield loss, but in fact, the data show that only 20% of the plants across all the data have been infested with fallen worm. So it's not the kind of damage that's projected. And finally, looking at this data, so if fallen worm did cause that billions of dollars of damage and yield loss, you would see some drop-off in the yield across Africa. And in fact, you don't. Unfortunately, it's only through 2020 here, but these are data from FAOStat, the world's best agriculture data collection, looking at the yield that is, let's say, bushels per acre in American terms. This is in tons per hectare. And you look at 2016, fallen worm first hit, 17, 18, 19, 20, no drop-off in average yield across Africa. So again, countering this narrative that fall armyworm is causing devastation across the continent and hunger. Not so. So working with smallholders and institutions that support them is what we did in FAO for a number of years that I led that program. Many countries, and I won't go into detail about where the programs worked, but we began to work and produce documents that were useful to countries' programs, a farmer field school guide, so kind of get to that question of what really is the context and needs of smallholder farmers for the corn production fall armyworm management, and produced guidance notes and recommendations on how to manage fall armyworm. So I'll just go over a couple of those, and I'm running out of time. Some of the options that we looked at. First of all, we developed some criteria of what smallholders really need. And obviously they need effective, low-cost, okay, there's this material that we produce in FAO for countries. And what do smallholders really need? They need effective, low-cost, safe, accessible, and sustainable management tactics, okay, in their context. Really should be based on agroecological knowledge. And it can be kind of simple agroecological knowledge, or it can be very deep agroecological knowledge. And we'll talk about that in a second. Most of them are very context specific. I mean, some of them are generalizable. We'll talk about some mechanisms that are generalizable. But really what a farmer is going to do in his or her field depends on their context. Okay? And so that's what you have to take into consideration. And that's what we had to kind of push against when we began to create the program for farmers across Africa. We got a lot of pushback. And I did personally, and people in FAO, because people came to us and said, yeah, but fall armyworm is devastating. It's causing massive crop loss and cause hunger, when in fact it wasn't. But that's part of a narrative that would lead to some of the following. For example, countries should provide or subsidize pesticides. And that was very strong in the first few years. There were countries that were giving away even nasty pesticides. I won't mention the country, but one country was giving away carbosulfan so that farmers could pick up this carbosulfan by hand and put it in the corn plants. I don't know if any of you pesticide experts here, but carbosulfan is a material that was banned by the European Union for human health concerns with WHO a number of years ago as a potential carcinogen. But that's just an example of bad things that happen when panic and kind of these narratives lead the way. So we had to push back against that. No, you don't need to subsidize pesticides. There are other ways to do it. The whole discussion around the use of GM maize or corn was omnipresent. Got lots of pressure from people who wanted us to introduce GM corn into Africa, get approval for it, because that would be a solution. And other people talked about other technology, drones, et cetera, that really are technologies that exist and can help some farmers manage their pests, but not for smallholders condition. And finally, people would push back against agroecological tactics, saying, oh, but they're way too labor intensive. And we don't want, the families and especially children out there in the fields. So that was part of our program. But what we did was push forward with this program, which I think led to some success, and I'll show you about that. First, just don't panic. Don't jump to pesticides. There are other ways to manage falling worm, and probably pesticides are not appropriate, even just from a simple economic calculation, not appropriate for farmers, smallholder farmers going forward. Two, start with the farmer's needs and their possibilities. You've got to challenge those narratives about yield loss all the time. And then really importantly, as I mentioned, first slide, building the partnerships between smallholder farmers, the institutions that support them, could be NGOs, could be local universities, could be Ministry of Agriculture, could be other support networks that are there for them, and connect them to researchers and international efforts to really understand the agroecological basis of fallen worm management as a starting point for recommendations. So that local institutional strengthening is something really important. And then once you have the knowledge, build appropriate policies, not policies like give away pesticides. So these were some of the areas of promising research, and I'll show them in a second, that we worked on. So as you know, fall armyworm has all kinds of natural enemies, things out there that feed on fall armyworm. So first, there are parasitoids, wasps that will parasitize the fall armyworm at different stages, eggs, larvae, pupa. There are predators. Ants are really important in the tropics as predators, especially a pupae of these fall armyworm, also the larvae. We looked at plant diversity. I think some of you had mentioned the push-pull technology that has been widely studied and used in Africa, and the role that diversity plays in push-pull. So how do you mix plants so that you have a chemical in the field that deters oviposition? And I'll talk about that in 1 second. So how diversity and push-pull can be used. Local botanicals, really important. Botanicals really do kill fall armyworm, all kinds of things, from neem to tephrosia to peppers, et cetera. The question is, how do you use that in a sustainable way? The intimate pathogens, I'll talk about in a second. So are there bacteria, fungi, virus? Those three groups are omnipresent in the environment, and they can do a good job of killing the fall armyworm if your field is managed correctly. Then the use of soil, sand, or ash is an important one too, which I'm going to end on. And then these really fundamental collaborations and partnerships of local people and international research. So diversity, just really quickly, because I don't have time. So back to Mesoamerica, Central America, traditional milpa production of the Mayans, where they grow their corn plant with their bean plant and their squash plant together. What are the advantages of that system? It's a traditional cropping system, is that it creates plant diversity. And in fact, when you plant just beans in a cornfield, because of the chemicals that the beans emit, fall armyworm moth, when she comes in to lay her eggs, doesn't like that smell, the odor. So you get 30% reduction in oviposition simply by planting beans in a cornfield. So that's just one example of how using diversity is really key and probably explains part of the evolution of such traditional systems such as the milpa in Central America. So the use of diversity, really important. Not only does diversity repel fall armyworm, but it can also encourage greater populations of those natural enemies. Those wasps provide an alternative food source for the wasp. The pathogens are in the environment more. So diversity both can push away the fall armyworm as well as attract the natural enemies that kill the fall armyworm. There have been, fortunately, lots of studies of these natural enemies and fall armyworm around the world and show that under good conditions, that is when you don't spray pesticides that kill the natural enemies or you use good diversity, you can get a very high level of naturally occurring control of fall armyworm. That is why when I worked in Central America, in Nicaragua, and I went out to the field and talked to some small campesino and asked them about fall armyworm, they said, meh, not a problem. And why is that? Because they use the traditional systems and they've got all these natural enemies and it's just not a big enough deal, even though it originated there, right? Of course, the milpa system originated there too, and the campesinos have been dealing with it for thousands of years. But literally, that was the reaction of smallholders in Central America. I was trying to do the opposite. I was trying to do my PhD and show how important it was. So that was a little. But there are tremendous natural enemies out there. And then people pushed back and said, oh yeah, but in Africa, those natural enemies aren't there. So we've got to use pesticides because they're not going to do good control. And just an anecdote to counter that example. So we were doing surveys across all the countries of Africa, looking where is it there yet, is it there yet? And my colleagues in Yemen, I couldn't go to Yemen because of security reasons, but my colleagues sent me photos of the first time fall armyworm was identified in Yemen because they were doing out scouting. And they sent me hundreds of photos. Is this fall armyworm? Is this fall armyworm? And they sent me this photo. And it is fall armyworm. It's been killed by a fungus. So even in Yemen, which you probably know, a desert country, not the kind of place you'd think of a fungus growing, or that would kill a fall armyworm recently arrived, just demonstrates clearly that some of the natural enemies are there. They can move from sister species, is the explanation. They're there and can do a good job. So the narrative that fall armyworm natural enemies aren't present, also not true. There have been efforts, so now we get down to the nitty-gritty of how to help farmers manage the fall armyworm, smallholders. Lots of efforts to locally produce some of these natural enemies. The parasitoids, you can rear trichogramma, which is a wasp that parasitizes the eggs and release them. You can raise the fungus especially and spray it, or the virus, and that's been done quite a bit. And in Brazil today, a lot of the corn production, there are local producers of trichogramma, and the farmers, even large-scale producers, will go out and release this wasp that parasitizes the eggs of fall armyworm and other sister species as a way of controlling their insect pests. But that requires a certain infrastructure and how do you get that to farmers, et cetera, but it's useful. And we can talk more about it from 3 to 4 this afternoon about those examples. There are many substances that kill fall armyworm, and this is documented in the literature. This is not some, farmers' knowledge only. Botanical solutions, many of them demonstrated in the literature to kill fall armyworm, local botanicals, soaps and oils, and soil and sand. Okay? And just real quickly, again, because I'm running out of time, these have now been published. So because FAO and others supported local institutions to build these collaborations, we have some great scientific literature now. For example, this one, low impact of fall armyworm. So this is another study to corroborate the first study I showed you, that in fact the yield loss in farmers' situation fields in Malawi, Zambia, very low. So again, just corroborating that idea that the yield loss to fall armyworm in smallholders maize cornfields is actually quite low. But these kinds of studies are coming out. Natural enemies of fall armyworm in Ghana. Natural occurrence of Bovaria, that's one of the fungus that kills fall armyworm in Congo, DR Congo. I mean, this is great work that local scientists and others are producing scientific literature from places that you wouldn't actually expect it. Evaluation of different management options, including parasitoids from Ethiopia, and pesticidal plants and fall armyworm, and that one is from Pakistan. Okay, so all kinds of studies being done. And this one, just to be a little nerdy about it, this is very interesting because the fungus, as I mentioned, can kill fall armyworm, certain fungi. Metarhizium is one of those fungi that kills fall armyworm. But not only is it present in the environment, but if you spray it on a plant, it becomes endophytic, that it grows in the corn plant, the fungus in the corn plant cells, and therefore protects the plant, kind of just like the GM idea. But it's a fascinating agroecological knowledge and approach to managing fall armyworm. And then finally, I'm going to end on this one, agroecological management using soil and botanical treatments from some colleagues in Malawi, doing some really great work. And I continue to work with colleagues in Malawi, and more recently in Kenya with an NGO called FIPS, maybe some of you know it. They have actually a grant from USAID through their window that provides grants to NGOs with support, people like myself, to help them do it. And we're showing really good results on the use of simple soil from the field of the corn plants put in directly in the whorl of controlling fall armyworm. Real quickly, soil, as you know, it's the mineral material, but it's also the biome and pathogens. So it can kill fall armyworm through a number of mechanisms, if you're interested in that. One, it can sort of, for small larvae, it can immobilize them, and they can suffocate. It's sort of very wet soil, depends on what kind of soil you use, of course. It can also abrade them. That's why we use boric acid for cockroaches because it just cuts their cuticle and they desiccate, another mechanism. And finally, the soil in the cornfields have all those pathogens. In fact, studies from Brazil and elsewhere have shown that 30% of the samples from cornfields have the virus that kills fall armyworm in the soil. And so it's, again, been studied. It's not just wishful thinking. So you can kill fall armyworm using soil through a number of mechanisms, and we found that it is widely adopted by smallholders in Kenya. The first round, after showing farmers this practice, 60% of the farmers on their own, when we went back out and checked if they were using it, were using it the next year. And so if there's any better evidence that something is working, I think that's it. The fact that farmers are actually doing it. So it's just something that I continue to work with FIPS and USAID on a project. We'll be publishing some papers soon on that. But I'm not trying to present that as a magic bullet, because there are many things I mentioned that I think if you all work closely in your context, understand the environment, the farmers, what's available, continue to work with researchers, you'll find some really fascinating, effective, low-cost, accessible management tactics for fall armyworm for smallholders. Thank you.
Mics. We may not have enough time to answer all your questions, but you can ask those on Huga, and also please attend the Meet the Speaker this afternoon. So any questions?
Yeah, you might have said it, but could you repeat what some of the consequences were of the overreaction to fall armyworm invading Africa?
Yeah, so first there were cases, and I mentioned the one in Kenya where they started giving away carbosulfan, a very dangerous pesticide, to farmers. So direct access and exposure, human health damage from that, so that's real clear. I saw that happen. Two, just kind of creating this narrative that that's what smallholders need. So we need to continue to give away pesticides to them or subsidize the pesticides. And that is really pernicious, because once that's there, once the Minister of Agriculture says that this is what we're going to do, and it's got backing from some donors who are giving them money to do that, that becomes the modus operandi, becomes the paradigm. And so real specific examples of bad pesticides being used to policy being put in place.
Usted habla español.
Claro que sí.
En Honduras, este gusano es el cogollero, ¿no?
Ajá.
Y hay un conocimiento generalizado allá de los agricultores que en un periodo seco él ataca. Entonces cuando viene la lluvia, él se ahoga. Entonces ellos confían en eso y no hacen mucho control, no se hace mucho control de este gusano. ¿Cuál es este conocimiento a nivel de otras regiones?
Le voy a contestar en inglés, ¿sí? Para todos. So he's asking about the, in Honduras, especially in drier times, when heavy rains come, smallholders always say, well, heavy rains came last night, I don't have any problem with fall armyworm, cogollero, as it's known in Central America, in my cornfields anymore. And it's absolutely true. So it's absolutely true. I was there doing that and worked with smallholders and saw it every time. Heavy rains do wash the small larvae off the leaves as they're crawling in from the egg masses on the leaves into the whorl. It actually does, as you described, drowns larvae, because the whorl could fill up with enough water, moisture. Probably also there's a pathogen effect there. The moisture is good for moving pathogens around there too, but they die. So after heavy rains, that's absolutely true. It's a great question in terms of how to generalize that knowledge across the world, something that we try to do with FAO and other projects, but we need to demonstrate that more so that farmers see it themselves. So that's how I think we have to continue to spread that information from Central America, which is absolutely true, and get farmers to begin to make their own observations and see that that's true themselves. So, es lo que digo.
So, excuse me. You said that when the farmers or the Ministry of Agriculture decides to go on the route of using pesticides, how do you, we're missionaries in Ethiopia, and we've been there during the time where the government decided to go this route. And we've seen this explosion of cancers and other issues that were never there before. I used to say Ethiopia had the cheapest organic diet, just go there. But now we're seeing these issues. How do you encourage the government and overall the country to go back to farming the way that it was done? Now they're doing GMO seeds for crops that only exist in Ethiopia before 20 years ago. They don't need it. So how do you get them to go back?
Yeah, it's a great question. It's not easy. I'll start off by saying that, but it's not impossible either. I think it depends on building. I mention often partnerships and coalitions, and part of that is not just to find the right tactics in a certain moment, but to build coalitions around these types of topics too. And it's important that you work with, as missionaries, local extension people, local researchers. Find some researcher from a local university who's interested in doing the study. Find some U.S. Organizations that are supporting this work, that are funding this work. Find the FAO people. I mean, you just have to build enough connections and sense that this is not the right way to go, and it's dangerous, as you described, and there are other ways to go, as we described here. So you just have to work on building that narrative and getting support for it.